Hey guys, welcome back to my channel. In this video, we'll be talking about resultant of coplanar non-concurrent force system and some examples. So, the magnitude and direction of non-concurrent forces can be obtained by resolving the forces along the two perpendicular directions. To obtain the position of the resultant force, equate the sum of moments of all the forces in the plane about any point in the plane, the moment of the resultant about the same plane, saying that we can use this Variables theorem, which is F into D is equal to F in 1 into D1 plus F2 D2. We can use that theorem here and we can solve any non-concurrent force systems. So here we are given an example here. We need to determine the resultant of the system of forces shown in figure. So here we are given a force like this. We're given forces like this, 10 kilonewton downwards, 20 kilonewton upwards, 20 kilonewton downwards, 10 kilonewton downwards. So first of all, what we'll do is that we'll find the resultant. So summation of h will be equal to 0 because there are no forces on the horizontal axis. So we'll just calculate the vertical forces, which are minus 10 plus 20 minus 20 minus 10. For that, we'll get an answer of minus 20 kilonewton. Then we get a resultant of 20 kilonewton. Okay, so we have got the value of 20 kilonewton, and the inclination is in 90 degrees because tan inverse of summation of h by this will become this. So tan inverse of infinity is equal to 90 degree. Okay. So now let the distance of the line of action of the forces from A is x. So here it will be from a point A, it is x. So we can take it as minus 20 into x. Summation of MA is equal to minus 20 into x. Okay, because what we need to find here is that x is that value of x is the value of the resultant from the point A, so it will be somewhere like this. Okay, so we need to find this value. To find that value, we can use the Variables theorem. So in this case it will be minus 10 into 0, then we have 20 into 4, then minus 20 into 10, then minus 10 into 17. So if we calculate this, we'll get minus 290 kilonewton meter. As we have got everything from this, we can find the value of x, which is 14.5 centimeters from A. So this is the way we do. This is the way we find the resultant of uh, coplanar non-concurrent force systems. So in the next case, we have four forces equal to 10 kilonewton, 20 newton, 30 newton and 40 newton are acting along the four sides of a square A, B, C, D. We need to find the magnitude, direction and position of the resultant for force side of the square. So we are given forces like this: 10 newton in this side, 20 newton in this side, 30 newton on this side, 40 newton on this side, all together forming a square. So we need to find the resultant r and the distance x. So if we find the horizontal forces, it is 10 minus 30, which is minus 20, and vertical forces will be 20 minus 40, which is again minus 20. So if we calculate the resultant, it is somewhere around 28.28. And to find alpha, it is tan inverse of summation v by summation h. So we get alpha is equal to 45 degree. So what it means is that the resultant is somewhere like this. Let us assume that the resultant is like this. Okay, which makes an angle of 45 degree. Now we need to find x. So x is the perpendicular distance between A and the line of action of the resultant force. Now taking the moments about A, we get summation of MA is equal to 28.28 into x. So in this case we have considered x to be in this manner, and this is the x which we need to find. So in this case, to find the moments, uh, here we have 10 into 0. Why are we having 0? Because it's in the same plane of action, so there's nothing happening. Then we have 20 into 1 because 1 is the perpendicular distance. Then we have 40 into 0 because 40 is in this direction and it is just on the point of action. And we have 30 into 1 because we have this 30 Newton force in the horizontal direction, but it is perpendicular to A by a distance of 1 meter. So totally we will be getting a value of 50. Now we can find the value of x just by using this equations again, and we will get x is equal to 1.768 meters. Okay, it's a little bit confusing, but if you do the practicing well, you can just ace it. Now let us move to the question number 3. We need to find the resultant of a set of coplanar forces acting on a lamina as shown in figure. Each square has a side of 10 millimeter. Um, so I recommend you to pause this video, try it in your own, and come back. So I hope you have just tried it out. So in the first case, we just need to find the angles. This theta 1, theta 2, and theta 3. Okay, so tan theta 1 here will be equal to 10 by 10, which is equal to 1. Because why are we taking 10 by 10? Because this each side is 10 millimeters, so it will be if you are taking tan theta, it will be 10 by 10, which is 1. So we know that tan inverse of 1 is equal to 45, so we can say that theta 1 is equal to 45. Similarly we can do for the other three cases, and we will get theta 1, theta 2, and theta 3. Now what we just need to do is that we need to find the resultant on the x-axis. So it will be uh, 2 cos 45, then 5 cos 36.87, 1.5 cos 26.565, and we'll get the value of rx, and similarly we'll get the value of ry. Now we can find the total r, which is 4.655 kilonewton, and similarly we can find the alpha also. Now we need to find the value of x. So resolving the forces into x and y components, and then finding the moment of the force about O, we get MO is equal to 2 cos 45 into 30, 5 sin 36.8750, and so on. So we get the value of MO to be 199.13 kilonewton meter. Then simple. Now we have got the value of M, we have got the value of R, and we can just find the value of D to be equal to 42.88 millimeter. Okay. So I hope you understood what I have taught. So let us move to the next question. So in this we need to determine the magnitude, direction, and position of the line of action of the resultant of the coplanar system of forces shown in figure. Uh, okay, so here we have a force like this, 850 Newton in this direction. We can find the theta 3 because we are given the slope. Slope will be equal to tan inverse of 15 by 8, so we'll get the value of theta 3, and similarly we can find the value of theta 1 and also theta 2. So if we find these values, it will be 61, 22, and 53 degrees respectively. Then after finding these, now we need to find the moments. So it will be 850 sine 1.316. So 850 sine 1.316 is will be something like this. Actually, this is the cos and this is the sine. Sorry, actually, I'm just confused. Minus 850 sine 6193 will be, if this is theta 3, then this won't be theta 3. This will be theta 3. Okay. If this is theta 3, then we can find 850 sine theta 3 will be this part. Okay. No, it will be this part. If we are getting that, and if we are multiplying it by 0.75, we will get the moment of this one. Similarly, we can find 500 uh, sine theta. Actually, we don't need to do that because it is in the point of action, and in this case we can find 650 sine 22.62 into 2.5. Okay, so we will get that. And similarly, we can find summation of h also. So here also it will be a 850 cos 61.93 into this length. Okay, we don't need that length because uh, it is not needed. Actually, we are doing summation of h here and summation of v here, and we'll get r is equal to this, alpha is equal to this. Then we can find the value of x also. Now we'll do the last problem here. We need to find the resultant of the system of forces shown in the figure and the point of intersection of its line of action with line AC and line CD. So in this case also we need to find the resultant of system of forces shown in the figure. So we have a force like this, 100 Newton force like this. Then we have a 200 Newton force like this. Then we have a 300 Newton force like this. Okay, and we need to find the line of action. Line of action in this case, first part is AC. Okay, so it is AC. We can consider any part. We can consider C, or else we can use A. The answer will always be the same. So summation of h will be equal to only 300, because 300 is the only force which is acting horizontally. Then summation of V will be 100 minus 200, which is minus 100 Newton. So from that we'll be getting the value of that resultant to be 316.23 Newton and alpha to be 18.435 degrees. Now if you are taking moment about A, this will be 0. Then we have minus 200 into 75, and then we are having a moment which is acting like this. If it is acting in the clockwise direction, it will be 0. It will be negative, sorry. So it will be minus 100. Then we have 300 into 75. Why? Because if you are taking this position, then this is the uh, point of action and this is the perpendicular distance. So we can write 300 into 75. From that we'll get a value of 7400 Newton meter in anti-clockwise direction. Now since MA is anti-clockwise, the point must be towards the left of A. Okay, so it should be towards the left of A. So the resultant will be somewhat like this. Then Rx is equal to summation of MA. From that we'll get x is equal to 23.44. Then we can find the value of angles A. Then we can find a EC, CF 93. It's all that. The basic thing is that please don't get confused with these signs. Do learn about that more, because if you have any misconceptions about the signs, the entire questions, entire answers will get wrong. And also understand it's nothing but the perpendicular distance multiplied by the horizontal point of action, and just multiply it. And Varignon's theorem is used everywhere, and you'll just get the answer. Okay, so in the next series we'll talk about parallel forces in a plane. So I'll end here. So thanks for watching with this video. I'll see you in the next one. Happy learning.